Today I want to talk about modular programming. We can say modular programming is when we break a program up into smaller, manageable functions or models. So when you have a program and you break it down into pieces, which we call them models or functions, we call that modular programming. It supports a divide and conquer approach to solving a problem. We have a function, which is a collection of statements to perform a specific task. So we have some motivation for modular programming. It simplifies the process of writing programs. It improves the maintainability of programs. We have a function, which is some statements that we put them together to do something specific. When you want to create a function, we have a function definition that includes the name, parameter list, body, and return type. Name is the name of the function. So when you want to give a function a name, you have to follow the naming rules. The parameter list will be the variables that hold the values that are passed to the function when it's called. The body of the functions are the statements that they perform the function's task. The return type will be the data type of the value the function returns, so the part of the program that called it. In this example here, we have this main function. This main is the name of your function. The parameter list is what you put inside the parentheses. You can see it's empty. The int is the return type, which is an integer. The body of this function has a cout, hello world, and return 0. So this is the first function that you run when you want to write when you want to call it, when you want to create a C++ program, which is the main function. So you can see this main function, it has int before it. This is the function that we use when we want to start a C++ program. We have a function header that consists of the function return type, the function name, and the function parameters. For example, int main, name of the function is main. This is the header. There is no semicolon at the end of the header. The functions, they can have return types. If a function returns a value, the type of the value must be indicated. When you have main function and you put int here, it means this function return type is integer. If a function does not return a value, its return type is a void. When you say print heading and you put void before that, it means the return type is void. If you say cout double left arrow monthly sales, you will display this monthly sales. Void means nothing. It means this function doesn't return anything. The return type is void. You could have functions that return nothing. When you want to call a function, you use the function name followed by parentheses and semicolon. For example, this function here, if you want to call it, you put the name of the function, you open close parentheses, and you put semicolon. When a function is called, the program executes the body of the function. After the function terminates, execution resumes to the calling model at the point of call. We can say main is automatically called when the program starts. Main can call any number of functions. Functions can call other functions. The first function that runs when you run your C++ program is the main function. From main function, you can call other functions. Your functions, they can have a prototype. The compiler must know the following about the function before it's called. Name of it, return type, number parameters, the data type of each parameter. So there are multiple ways to notify the compiler about a function before making a call to a function. We could place the function definition before the calling function definition. We could use a function prototype similar to the header of the function. In this example, void print heading is the header. Void print heading, open close parenthesis, semicolon is the prototype. Prototype and the header are very similar. The difference is that the prototype has a semicolon after that. The prototype will inform the computer, the compiler, that you have a function, that this is the name of it. It doesn't take any arguments. The return type is void. We place prototypes near the top of the program. A program must include either a prototype or a function call, function definition, before any call to the function. Otherwise, a compiler error occurs. So when using prototypes, the function definitions can be placed in any order in the source file. Traditionally, main is placed first. These are some notes in the prototype. So when you want to send data into a function, you put the name of the function, you pass the arguments. You can pass values into a function at time of a call. Values passed to a function are called arguments. Variables in a function that hold values passed as arguments are parameters. We have alternate names, like for arguments, we call them actual argument, actual parameter. For parameters, we call them formal argument or formal parameter. So when you want to call a function, you will pass something to that function. Those are what we call them arguments. The value of arguments will get copied into the parameters that the function has. For each function argument, the prototype must include the data type of each parameter as an open close parenthesis. For example, void, even or odd, int. The data type for the parameter is integer. Or you can say void, even or odd, int num. This num is an integer parameter. This is the prototype. The header must include a declaration with a variable type and name for each parameter in this open close parenthesis. Void, even or odd, int num is the function header. The call for the above function should look like even or odd parenthesis val. No data type on argument and call. So when you have a function and you want to call it, you put the name of the function. You open and close parentheses. If the function has and does take any arguments, you pass them there. If the function does not take any arguments, you just open and close parentheses. The value of the argument is copied into the parameter when the function is called. A function can have more than one parameter. There must be a data type listed in the prototype and an argument declaration in the function heading for each parameter. Arguments will be promoted or demoted as necessary to match parameters. Be careful. So these are some notes on functions calls. So when you call a function with multiple arguments, the number of arguments and the call must match the function prototype and definition. The value of the first argument will get copied into the first parameter. The value of the second argument will get copied into the second parameter, and etc. You can see when I call this function height and weight, the height will get copied into h. Weight will get copied into w. The function header takes h and w. The weight will be display h, and then for the height, it will display w. This is how you can call functions with multiple arguments. You could pass data by value. When we say pass by value, when an argument is passed to a function, a copy of its value is placed in the parameter. The function cannot access the original argument. Changes made to the parameter in the function do not affect the value of the argument in the calling function. So when we talk about pass by value, it means you're calling the function and you're passing that value to it. In this example, I say int val equal to 5, even or odd val. When you call this function, this variable val is 5. This val becomes 5. The function will receive this variable as a 5, which means that you're passing the value of 5 to this function. The argument in the calling function, the val is 5. The parameter in even or odd function, the num becomes 5. Even or odd may change the variable num, but it will have no effect on variable val. The return statement is used to end execution of a function. It can be placed anywhere in a function. Statements that follow the return statement will not be executed. It can be used to prevent abnormal termination of program. Without a return statement, the function ends at its last closing brace. We can say the return statement is end of a function. Whenever your function gets to a return, it stops. If you don't have a return statement, your function will end when you have a closing brace. You could return a value from a function. The return statement can be used to return a value from a function to the model that made the function call. The prototype and function header must indicate the data type of return value, not void. The calling function should use the return value, assign it to a variable, send it to cout, use it to an arithmetic computation, use it in a relational expression. So when you want to return a value, you can use the return statement. You can say return, and then you put an expression there. The expression may be a variable, a literal value, or an expression. The expression should be of the same data type as declared return type of the function. You could have functions that they return something. Whatever you put in the return after the return, it has to match the data type that your function returns. You could return a Boolean value. A function can return true or false. You can declare the return type in the function prototype and header as bool. The function body must contain return statements that return true, false, or bool variables or expressions. The calling function can use the return value in a relational expression. In this example here, we have a function which is valid. It has a parameter val, which is integer type. It does have a return type, which is a Boolean. You can see this function has a return statement here, which if this condition is true, the return will be true. The min and max are integers, then there are 0 and 100. If the val is greater or equal to min, and the val is less equal to max, it will return true, otherwise it will return false. When you say if is valid score, if this function gives you true, then something may happen. This function is returning a Boolean variable. It means the return type will be either true or false. This is an example of a function that returns a bool. So a programming style may calculate a return value and use a single return statement. The previous example could be written as bool is valid. This function, we can write it like this. We can define a bool result. We can define min and max as 0 and 100. We could say if val is greater or equal to min and val is less equal to max, result becomes true, else result becomes false, return result. So if you look at this example here, at this one, you can see here we're returning true or false. Here, we're just putting true or false on the result, and then we're returning it. Functions can be used to implement user choices from menus, to implement general purpose tasks. Higher level functions can call general purpose functions. This minimizes the total number of functions and speeds program development time. We have some screen management and menu-driven program. You can clear the screen to remove prior output while program is running. In Windows, you can say system and then CLS. In Linux and Macs, you can call system with clear. This will clear your screen. To allow the user enough time to read output before the screen clears, use this code. Cout press the empty key to continue. We can say cn.get to clear the input buffer. You can say cn.get to get the enter key. We have local and global variables. Local variable is defined within a function or a block. It's accessible only within the function or the block. Parameters are also local variables. Other functions and blocks can define variables with the same name. When a function is called, local variables in the calling functions are not accessible from within the function call. When we say we have a variable that is local, it means it's accessible only within a specific scope. We say a local variable only exists while it's defining function is executing. Local variables created when a function begins and are destroyed when the function terminates. When you define a local variable, it's born. When the function ends, it dies. Data cannot be retained in local variables between calls to the function in which they are defined. We could have global variables, which is a variable defined outside all functions. It is accessible to all functions within a scope. It's an easy way to share large amounts of data between functions. The scope of a global variable is from its point of definition to program end. Try not to use global variables often. So the global variables, they have a scope that is all of the program. The local variables, they have a scope that is a specific part of a program. I'll give you guys examples of local and global variables to understand it better. Local variables must be initialized by programmer. Global variables are initialized to 0 or null when the variable is defined. These can be overridden with explicit initial values. So why should we use sparingly like the global variables? The global variables makes programs that are difficult to debug. Functions that cannot easily be reused in other programs. Programs that are hard to understand. Try not to use global variables. Try to use local variables as much as possible. We can have a global constant, which is a named constant that can be used by every function in the program. It is useful if there are unchanging values that are used throughout the program. They're safer to use than global variables, since the value of a constant cannot be modified during program execution. When you have a global constant, it means you're defining a constant that is global. It means everywhere is accessible and it is constant because it couldn't change. You can have local variables that have the same name as a global variable. When a function contains a local variable that has the same name as a global variable, the global variable is unavailable from within the function. The local definition hides or shadows the global definition. It means if you have a local function that has the same name with your global function, it will override that global function in that scope. So the local variables, we have a static local variables. They only exist while the function is executing. They are redefined each time function is called. They lose their content when function terminates. We have a static local variables that are defined with word static. Like when you say a static int counter, you're defining a static local variable. They're defined and initialized only the first time the function is executed. They return their values between the functions calls. When you make a variable static, it means it can keep the value. Whenever you have several function calls, that local variable, that static local variable keeps retaining the information and the data. You could have default arguments. We say values that are passed automatically if the arguments are missing from a function call. There are default arguments. Must be a constant or literal declared in the prototype or header. When you say void even or odd int x equal to 0, you're defining this x as an integer and you're giving it a default value of 0. You can have multi-parameter functions that may have default arguments from some other parameters. Like when you say int get some int. These two arguments, they can be 0. These two parameters, they can be 0. Because by default, you're putting 0 there. If not all parameters to a function have default values, the ones without defaults must be declared first in the parameter list. For example, int getSum, int. This first one doesn't have a default value. These two, they do have default values. Int getSum, int. This is wrong, because this one doesn't have a default value. This second one does have. When an argument is omitted from a function call, all arguments after it must also be omitted. Like sum equal to getSum num1, num2 is okay. Sum equal to getSum num1, num3 is wrong. You couldn't do this. You could use reference variables as parameters. So I did talk about pass by value. We can also use a pass by reference, which this is a mechanism that allows a function to work with the original argument from the function call, not a copy of the argument. It allows the function to modify values stored in the calling environment. It provides a way for the function to return more than one value. We have a reference variable, which is an alias for another variable. It is defined with an ampersand in the prototype and the header. For example, void get dimensions int ampersand and ampersand. This function is taking two reference variables. Changes made to the reference variable are made to the variable it refers to. We use reference variables to implement passing parameters by reference. In this example, we have a function. We say int ampersand in the prototype. This ampersand is a reference. When you say void square root int ampersand num, this num is a reference variable. You multiply num by num. If you call this function and the local var is 5, the 5 will get copied inside this num. It will get multiplied by 5. And then it will affect the variable that is being passed to it. And pass by reference, any changes to the variable can change the variable that was passed to the calling function. That is why we call it pass by reference. Whenever you put ampersand here in your function, that is a pass by reference function. Each reference parameter must contain ampersand. An argument passed to a reference parameter must be a variable. It cannot be an expression or a constant. We use only when it's appropriate, such as when the function must input or change the value of the argument passed to it. The false string objects should be passed by reference. We can overload functions. The signature of a function is defined name and the data type of the parameter in order. Overloaded functions are two or more functions that have the same name but different signatures. This can be used to create functions that perform the same task but take different parameter types or a different number of parameters. The compiler will determine which version of the function to call by the argument and parameter lists. In this example, you see how we can overload functions. Get dimensions is overloaded. It could take one integer. It can take two integers. It can take an integer and a float. It could take two doubles. In this program, this get dimensions is overloaded 4 times. Then the compiler will use as the following. If you have int length width and you have double base height, if you say get dimensions length, it will use length, which is an integer variable. It will use the first one. If you say get dimensions height and width, it will use the second version of the function. If you call get dimensions with length and height, it will use the third version, which takes an integer and a float. If you say get dimensions height and base, it will use the version of the function that takes a double and a double, two doubles. This is overloading. Overloading means to have functions that they have same name but different signatures. The exit function terminates the execution of a program. It can be called from any function. It can pass a value to operating system to indicate the status of program execution. It's usually used for abnormal termination of program. It requires a cscdlib header file. Use it with care. With the exit function, you can exit your program. So use an integer value to indicate program status. Often 0 means a successful completion. Non-zero indicates a failure. We can use name constants defined in cscdlib like exit success or exit failure. We say a stub is a dummy function in place for an actual function. It is usually displays a message indicating it was called. May also display parameters. Driver is a function that tests a function by calling it. Stubs and drivers are useful for testing and debugging program logic and design.